Okay, so previous two videos we talk about the axial loading and the transverse loading. Alright, and we say that we want to go to shear loading. But however, alright, in between, alright, there is something that deals with the axial loading and the transverse loading that I'm gonna discuss now. Okay, in terms of manufacturing, how do I say? I don't know. But anyway, let's start. Okay. So there is a need of conversion between the weight of the fiber and the volume of the fiber. Okay, and the reason behind this conversion is because in production, or it is more convenient to work in terms of weight. Alright, but for our case, or in terms of composite materials, the densities aren't very easy to. It's not easy to determine. Alright, and therefore it is easier to somewhat deal with things in terms of a volume. Alright, and this makes things easier to deal with things lah. Okay, so therefore in calculations normally we deal with volume, but in terms of production we deal with the weight. Alright, and this is the formula for the conversion. Alright, as such, let's find a way to actually derive the conversion. Alright, because currently I also don't know what am I doing, but because I didn't copy properly, but never mind, let's see how it goes. Okay, and this is a very chim thing that I spent a long time, I think 1 hour already. I searching for the things that is needed, and I could say is that the weighting fraction of the fiber. Okay, the weighting fraction of the fiber we can rewrite as equals to the density of the fiber times the volume of the fiber. Okay, is that if you remember, mass over volume is equals to density. Alright, density kg over meter cube. Alright, mass over volume equals to density. So therefore, using this understanding, the weight is somewhat the mass. It's proportional to weight. The mass is proportional to weight. Alright. So with this understanding, the fraction of the fiber, or the weight fraction of the fiber, meaning fraction means that the weight of the composite is equals to 1. So fraction of the fiber maybe is 0.6 or maybe 3/5, things like that. Okay, so the fraction of the fiber is the weight, or sorry, the mass, alright, the density times the volume divided by, okay, the total mass, which is this thing, density times the volume of the fiber plus density of the matrix times the volume of the matrix. Okay, so mass over volume is equals to density. In case you don't know what the hell I'm doing, is that the density times volume, if I were to bring this volume up, mass is equals to density times volume. Okay, and therefore I have this dude over here. Okay, and since we know that in terms of fractions, how do I say, the VF fiber plus the matrix of the volume is equals to 1. Alright, and therefore the matrix, the volume fraction of the matrix is equals to 1 minus VF. So I can simply rewrite my VM as equals to this. Okay, so therefore as you can see, your VM is changed to this one. Okay, and if you were to compare, this thing over here that I'll derive is the same as the one in the presentation slide. Okay, although I can derive this, but I cannot derive what the lecturer has derived, and I'll briefly go through. But in this case, I just want to also prove that WF plus WM is equals to 1. Okay, so how do I do this? Oh, okay. So what I think is that the lecturer is taking the weight function. Is it? Let's derive what the lecturer has derived, and maybe we can get some link to it. Okay, so he actually has, first he derived W, the capital W, as equals to the weight of the composite. He denotes the capital as typically the weight, and while he denotes the omega, or the small capital W, as the weight function. Alright, so it's a function, and I will assume that this function, WC, is talking about this thing. Alright, this is the function that end up you get this total weight of the composite. So it's trying to rewrite this in terms of that. Alright, while the weight of the composite is just the total weight of the composite, this one is the weighting function of the composite. That's why it's a little bit chim already. But anyway, if you were to apply this into our scenario, for example, the weight of the composite is equals to the weight fraction of the fiber plus the weight fraction of the matrix. So for example, if this is 60% of the weight for the matrix, this will be 40%. In total, they are 100%. Okay, so if I were to utilize, alright, I would say that this WF is this one. Okay, I shouldn't have said that. Okay, I will divide everything by the weight function of the composite divided by omega c. Okay, so it's all small capital. Maybe I should change a different color. Better, I think it'll be better. Okay, just a warning. Okay, a warning. If you find this very boring, I think you'll just skip. Okay, the next few minutes will be a bit boring, but the key takeaway is what I've derived is this one. If they ask you to convert the volume fraction, alright, into a weight fraction for the fiber, for example, then you use this formula. That's all it is. And how you derive it? You derive it based on this understanding. Okay, it's the amount of fraction of the weight of your fiber divided by everything, fiber plus the matrix. Alright, so this is the weight of the fiber plus the weight of the matrix. It will give you the total weight of the composite. So it's a fraction between the fiber and the composite, give you the total weight fraction of the fiber. Okay, so you just need to know this thing will do. Okay, well, how did I actually derive, I'm trying to derive now. Okay, just for the sake of for the future or whatever thing that may come. Okay, so therefore if you are keen, you just continue. If not, then you can skip to the next video already. Alright, before you go, I just want to tell you or inform you that we convert. Why do we convert is because if you think about it in the previous section, alright, we write things in terms of Young modulus. For example, this is the transverse, the Wells estimate loading. Okay, everything is in terms of the volume fraction. So if you can just sub in your volume in terms of the weight, okay, so therefore you rearrange in terms of volume. So WF multiplied by this whole thing I name it as A lah. Okay, so WF times A divided by rho is equals to VF. So you know, so you'll find your volume fraction is equals to this thing. Then you sub in all this after you rearrange all this lah. Okay, and then you sub in inside here, and you can calculate for your Young modulus also. Okay, so these are the little methods that you may have. So if in the exam they give you the weight fraction, at least you can convert into the volume fraction, then you can calculate. Okay, so this is the key concept that I just want to convey in this system lah. Okay, and therefore yeah, let's continue with the lecturers one, because the lecture ones deal with weighting functions which I didn't, I don't know what, but in the future it may be useful. So you can go to next video now. If you want to continue, but don't expect any good results lah. Okay, so yeah, where am I? Repeat again, you can just go to the next video now. This is for my personal learning already. So this is the weighting function of the fiber, weighting function of the matrix. Okay, and the next thing I copied is that they actually say that the weight, the what is this called? The weight of the composite is equals to the weighting function of the composite. Okay, and I don't even know what is the weighting function. That's the thing. Okay, so therefore I would then he write as 1, then equals to, and I will assume that this thing is highly the same as this thing. Okay, and yeah, I don't know. Then this is why after that I copy is that he rewrite everything. This is the big M as WC. Okay, he rewrite everything divided by WC, which implies that this thing and this thing is the same, which is pretty much true, because for the weighting function, for the weighting function of the fiber divided by the whole function of the composite, so I will assume that should be C, and this should be C also. So maybe it's either I copy wrongly, or there is other meanings within this thing. Okay, but nonetheless, this is the next step that he has done, and then he what and then not he but I copy like that. Okay, and I don't even know how this one come about already, you see, which is equals to, and there he goes, he's write all this. Okay. So what I thought is that in fact this thing over here is this one, but I don't know why this one, yeah, that's why this is where I stuck very long. And then I search this website. Alright, you can search this website also. Alright, this one. Okay, you can search weight fraction, and then I don't know, go where. You just type this one, okay, fiber packing, whatever. Just type in this. You eventually find this one, which the equation also a bit weird. Alright, just go through one thing is that over here is pretty nice already. Your volume, and suddenly he expand your volume as fiber times volume. I don't even know what the fiber, I don't know what the hell. Alright, and F is the weight fraction of the volume. So is the fraction of the volume, is it, or what? And makes things a little bit more complicated. That's why I only can take in here and there. So this is the weight fraction, which I think is very useful. This is the mass of the fiber divided by mass of the fiber plus mass of the matrix. And this is why, in other words, this is the whole mass of the composite. So mass of the fiber divided by mass of the composite lah. Okay, so this is why this gives me the inspiration of deriving the equation that I've earlier said. Is it this one? Where am I? Yeah, it should be this one. Yeah, this is the one. So therefore this is the thing lah. Alright, so I think you can just take this for the sake of taking it. Alright, although there is a little bit not true, because it is in terms of weight, you see. Weight is in terms of meter per second square. Alright, while your mass is just kg. So there is a SI unit contrast, you know, but it's proportional, so yeah, that's why I cannot say anything lah. But so far this derivations seems legit enough. Okay, so I think that's all. And yeah lor, so I'll leave you to think about it in the future lah, yourself. And next video, yeah lor, I think yeah, a few videos, sibei sian.